What I'm going to try to do here for just a couple of minutes is rapidly set the external context of what's going on. And I'm going to take off my hat as an academic for a moment and put my hat as a business person on, in the sense that in the outside market environment, we don't have the luxury of failing to position the role and responsibility of these tools because our livelihoods depend on it. And as a consequence, and as a business, we've made a significant investment in this concept to at this rate of about $250 million we've spent on this project so far. And so for us, it's a very serious undertaking, and we've had to be extremely disciplined about what we think the implications are for the folks who are ultimately our paying customers, who are practitioners. So I'm going to very rapidly, like in 10 or so minutes, kind of position the problem and then suggest to you what the resulting challenges are. So now let's talk about the technological issues. The acceleration of technological capability is happening extremely rapidly in the marketplace. And on top of that, and it's really the transition from here to here that the opportunity of building information modeling becomes possible, because computation becomes cheap enough and available enough to the people making the 6% margins that they can actually begin to implement it. The theoretical idea of building information modeling has been around for, what would you say, John, 35 years, right? We're only now, 35 years later, getting it on the desktops of designers. Now, in addition to the possibilities of the technology and the abstract discussion that we're having here, the adoption numbers have accelerated very, very rapidly. After when we did the Revit acquisition in 2002, the following year we did an awareness survey to see how many American architects had ever heard the term building information modeling, and the number was below 10%. 7 years later, which is a relatively short period of time in the history of our profession, the last McGraw-Hill survey suggested that 60% of all the architecture, engineering, and construction firms in the United States will have implemented some form of BIM technology by next year. So we've gone from 0 to 60 in 7 or 7.5 years, which is really rapid adoption. All the technology gets delivered in what we call the 3-screen dilemma, that all information and knowledge gets delivered to one of 3 screens, and you have to be agnostic as to which one. One of those screens is the desktop, which is this kind of traditional relationship. One is the web, which is delivered to you over the internet, and one is mobile computing. In particular, with the advent of the iPad, I think you're going to see some significant changes there. But at the same time, all this computation power is being applied to the back end of the process. The ability to document and understand existing conditions creates an overlay of significantly greater interest. This is a project that we ran last year to do a laser scan of the National Building Museum in Washington. Took a crew out there. It took them about 3 days. They did a high-resolution, I think it was a 7 billion point high-res scan of the National Building Museum. And what you're looking at here is actually what is essentially a high-res 3D photograph of the interior of the building, completely texture mapped. Then we rapidly converted that to a model, which allowed us to begin to do this. So within 3 days, we were able to capture the existing conditions of a 150,000 square foot building and begin reasoning about, in this case, the energy performance of that building. And so this idea of this, to go back to Rose's concept of this fascination with initial production, the definition of the proposition of initial production is actually going to change, because our ability to capture existing conditions at various degrees of resolution is now changed pretty fundamentally. And so if you take a bunch of these ideas to their logical extension, you start to see some really interesting things happening, right? The point I'm trying to make is that there's been this enormous explosion in the types of information that have to be mediated in order to control the overall design process. And at the same time, this tension that we talked about in Building the Future, this idea that in the traditional relationship between the consumer of the product, the conceptualizer of the product, and the executor of the project, these traditional paradigms of design intent versus design execution, the certified designers on the left and the uncertified builders on the right, and the folks who are not allowed to think about construction on the left and the folks who are only allowed to think about construction but not allowed to think about design on the right, this paradigm is beginning to collapse in on itself, because the technologies are starting to build a bridge between these two between this relationship and there's an increasing realization that we have to face that set of questions in order to address these productivity questions and these economic efficiency questions. So again, this is really a view of the problem from the outside world, and it's being remediated in lots of scientific experimentation around the roles and relationships between the players. And we won't get into a detailed discussion here about what I'll call in quotes integrated project delivery. But what the integrated project delivery movement in this country is challenging is all of the traditional roles, responsibilities, and relationships of the players in the overall process, including the actual definitions of how architects and engineers and owners collaborate, how they share risk, and how they define outcomes which become the predicate condition of projects themselves. And if you look at the IPD movement or the sustainability movement, what you begin to see is a shift in the practice world from structures that are predicated on limited economic circumstances to project delivery strategies that are based on outcomes. In other words, you don't get your money unless the project achieves its outcomes. Your economic well-being on a project is a function of being able to predetermine how the project is going to behave and how you're going to measure it at the end, which is a different kind of value proposition for everyone involved, but involves destroying all the normative structures of project delivery, all of them, every single one. And there's an interesting proposition there that we can kind of talk about going forward. So let me conclude with just a couple more thoughts. The other part of the equation that at least we're starting to see as we observe the implications of the use of technology in the outside world is that this delamination between design activity and construction activity is creating all sorts of really, really interesting phenomena. So here in the upper left is the Gary Technologies guys stuff that we're all very, very familiar with about kind of removing that barrier between design intent and construction execution. This is a set of diagrams that Greg Pasquarelli from SHOP actually showed in Hastings Hall a few years ago to our students during a lecture. I think I'm the only other person who shows project delivery organizational diagrams in Hastings Hall besides Greg, and he talked about these kinds of ideas as design ideas for how their actual practice is organized, premediated or kind of permeated by the idea of technology. This is a very, very dangerous document from Gluck Architects down in New York, explaining to a contractor in North Carolina the exact construction sequence of how to build a foundation of a house that they're designing down there. At one level, that seems like a very, very prosaic diagram. On another level, it fundamentally challenges many of the precepts that we are obliged to tell our students that they are not involved in the means and methods of construction, that they're in fact supposed to stay away from all those sorts of things, and it's the contractor's responsibility. The most interesting picture, though, may be this one here. This is our student Pierce Reynoldson. Remember Pierce, right? So Pierce now works for a construction company outside of Boston, a very hip construction company called Tachi Constructors. They have a small group of architects who are their modeling team, which they use to create building information models of projects when they don't get the models from the architects, or the models that they get from the architects don't work very well. And what Pierce is doing here is he's running a seminar series that they do every Thursday night for everybody in this construction firm on the history of architecture and what it means to be an architect and what architects do. And he's acculturating this construction firm to architecture. What Tachi's really saying there, and a number of contractors are having this discussion, is they're building up a lot of design capabilities internally. They're hiring a lot of unemployed architects, and they're creating design mechanisms within their organizations. And it's a very short jump from a modeling team to an architecture practice in that context. So in the marketplace, this kind of remediation between these relationships, I think, is something that we have to be kind of conscious of. So let me finish with a couple of thoughts about this. So this is Peter Beck, who was trained as an architect at Princeton. His father was an old-line Dallas contractor, and he went down to Dallas and reformed his construction firm. And he said, in an article he wrote a couple of years ago, he said, eventually contractors will learn from their use of BIM technologies to assume responsibility for design production and ultimately seek to be the architect of record. The risks they assume pale in comparison to those assumed by not integrating, because they already bear much of the cost and delay risk resulting from inaccurate information. This transformation could be tragic for the design profession and perhaps even for our society as a whole. Too many projects delivered using these integrated methods appear to be designed by the contractor. So here's Peter Beck, who understands this problem quite clearly, in fact has a small software company that he runs on the side, and he's worried about the effect of this problem. And so one of the ways to look at this is that there are three possible outcomes in this circumstance in the outside world. Outcome number one is what Peter describes, and the contractors just take over, and the architects are kind of disintermediated, and we just become aesthetic consultants. Now, at the other side of the continuum is our faculty colleague, Mr. Gary, who said a couple of years ago at a lecture here, the way I see it, the computer puts architects back in the driver's seat because we control all that information. So this is just a pure suggestion that by consolidating knowledge, you also consolidate control, and then you can return back to the traditional models of the architect as master builder and so forth. But finally, here's kind of outcome number three, and this is from Dan Friedman, who is the dean at the University of Washington now. And here's what he said. At a certain level, BIM begs the question of professional sovereignty over the relationship between what buildings mean and how they're made. In principle, any properly trained BIM technician, working for a contractor even, can produce highly authoritative construction documents with design quality notwithstanding. And this really goes back to Peggy's comments earlier about how we incorporate that. By extension, it is not difficult to imagine a market where certain owners asked architects merely for design services, leaving control of construction documentation and building production in the hands of others, technicians, contractors, or engineers. No less likely, however, is a market where the architect controls information and manages or even coaches team relationships, guiding dynamic decision-making from program through schematic design through construction, et cetera, et cetera. And what Dan's really saying here is, or what he's suggesting is, as architects, we have to decide whether or not we are going to incorporate these kinds of responsibilities as part of the design process. And I think that's very analogous to what the propositions that Peggy was putting forth there. What I want to suggest to you just quickly in closing here is if we look at Peggy's three options, where option 0 is wait to see what happens, the problem will be redefined for us by these large-scale forces in the marketplace. And we'll have virtually no influence over it, in my view. So we have to look at Peggy's option 2 or Peggy's option number 3, in my view, unless we want these external forces to define the problem. Before the downturn in the U.S. construction economy, there were 12 million construction workers and about 280,000 architects and architectural professionals in this country. And now about 30% of all those people are unemployed, meaning that there are less than 200,000 architects trying to understand the work of 9 or 10 million construction workers. So where we have the opportunities to understand these forces and translate them into an intelligent definition of what it means to train an architect, we should do so. Otherwise, in my own view, the marketplace will do it for us. So I know that's not what Martin was going to talk about, but I think this probably gives us enough of a context of what's happening in the outside world to process this problem.